Good day everyone, welcome to another video tutorial. Today we're going to tackle about graphing polynomial function. This is a part 2 video, so if you missed part 1, just go and search my channel for it, and it will help you a lot. So today we're going to graph a polynomial function, and we need to consider the following: the end behavior of the graph, the x and y intercepts, the turning points, and the multiplicity. We again, disclaimer, this is only a rough graph and it has nothing to do with the accurate graph of a polynomial function. Just doing a rough graph of it. Now, if you want to find more about this, I discussed this on my part 1 video for this tutorial. Now we're going to graph these three polynomial functions. So let's start. For the first polynomial function, we have x raised to 4 plus x raised to 3 minus 7x squared minus x plus 6. So to graph this, we need to at least lessen the list of the number that we should test in order to get our zeros. Now to do that, we just need to apply the rational root theorem, wherein we get the factor of the leading coefficient. This is 1. The factor of that is positive negative 1. And we need to get the factor of this. Positive negative 1, positive negative 2, positive negative 3, and positive negative 6. Now we're going to divide all of this with all of this. So we have positive negative 1 to positive negative divided by positive negative 1. Since we divide by 1, we have a list of positive negative 1, positive negative 2, positive negative 3, sorry, positive negative 4, no, positive negative 6. So these are the list of our possible zeros. So using synthetic division, we will test all these numbers until we get a remainder of zeros, a remainder of 0. And if we have a remainder of 0, therefore the one that we test is a 0 of this polynomial function. So let's try. So again, I will just write the leading coefficients of all the terms. 1, 1, negative 7, 1, negative 1, positive 6. So these are all of them. Then from the sets or from the list of my possible zeros, I will choose a number. It is nice if you will start choosing the least number so that it would be easy for you to do addition, subtraction, and multiplication. So in this one, I will choose 1. So I will bring down 1. 1 times 1 is 1. 1 times 1 is 1. We put the answer here. So if you want a review on synthetic division, you can find a video in my channel as well. Then let's combine this. Then multiply again. 1 times 2, we have 2. Then combine this again. Negative 7 plus 2 is negative 5. Then 1 times negative 5 is negative 5. Negative 1 plus negative 5 is negative 6. Then we multiply by 1. That will become negative 6, and we add that is 0. Now if you get the factor of 6 divided by factor of 1, if you test it, for example, you test 3 and you don't get 0, just cross out that 3 and try another number. Your goal is to get a 0 here. So after you get 0, you are sure now that this one is a value of x here. So you can write that as x minus 1. Okay? Now using the remaining numbers here, you could just test another number again. Again, let's just start with the lesser number so that it would be easy for you to compute and to test. So I will test negative 1. 1 times negative 1 is negative 1. Combine, we have positive 1, then negative 1. If we multiply this one, if we combine this, we have negative 6. Now negative 1 multiplied by negative 6, the same sign, we get positive 6. And if we combine this, we get 1, a 0. So therefore, it is a x again. It is a factor again. So now let's try another using the remaining number, or you could just put a coefficient here, x squared, 1, and 0. Or you can get, if you simplify this, you get x squared. This one is plus x, then minus 6. You could just factor this out. Mm, what is the factor of this? This is x here. X here, since it is negative, we need to put a different sign here. Now, what is the factor of 6? That if we subtract to each other, the answer is 1. So that is 2 times 3. So since this is positive, you put the larger number here, 3 and 2. 2 times 3 is 6. So these are the factor, then you could compute it. X is equal to negative 3 and x is equal to positive 2. So if you don't want that, you could just continue trial and error. This time I will choose 2. I'll do the synthetic division and I get 0. Then this is x raised to 1 and x raised to 0. Always start at x raised to 0, going to the left, increasing the number of degree. So if we simplify this one, we get x plus 3 is equal to 0. Then you subtract 3 on both sides, and you get as x is equal to negative 3. So these are now our values of x that would make this equation 0. If I'm going to rewrite it in a factor form, I should write it as x minus 1. See as the sign will become negative. This is x plus 1. This is x minus 2 and x minus 3. Okay. This one could explain why negative 3 become x plus 3. Sorry, this is x plus 3. Okay. Now if you multiply this, you will get this. Okay. So these are the list of our x-intercepts. 1, 0, negative 1, 0, 2, 0, and negative 3, 0. Now to solve for the y-intercept, all you need to do is to equate the equation to y and substitute 0 to x because y-intercept is the value of y when x is equal to 0. So this will give us 0, 0, 0, and 0. So our value of y if x is 0 is 6. So we have our y-intercept as 0, 6. If there are polynomial functions here, if there are variables here, x, you could just look at the what do you call this? Sorry, you could just look up the constant term that is our y-intercept. Now, as a recap, we have our x-intercepts and our y-intercepts. We need to plot all these points. We have 1, 0. This is the 1, 0. Negative 1, 0. Hope you could follow my sketch. 2, 0. And negative 3, 1, 2, 3, 0. Now let's look at our turning points. How many turning points do we have? We have 4 minus 1, maximum of 3 turning points. To get the turning points, get the degree minus 1. So 4 minus 1 is equal to 3. So that's we have maximum of 3 turning points. Now our end behavior is positive and even. So we have rises to both left and right. Just check my previous video and then where I explain how to get the x behavior. But for now, if it is positive, the leading coefficient is positive, and it has a degree of odd or even, we have rises to both left and right. And then we connect it now. Oh, sorry. This is just a rough draft. This is not the actual draft. Now, you see that we have no multiplicity. That's why all our graph crosses x-axis. No one touches x-axis. All of them crosses x-axis. That's why we have that graph. So I hope you learn this rough graph of this equation. Okay, these are all the things that we need to get at least a close rough graph. Now let's try this one. Okay, we could factor this out, the negative here. so that we could get this. The value of x is 0. I just factor that out because we have a common monomial factor, and it will become easy for us to factor this if we do this. So now our new form is this. Okay, so let's solve for x-intercept. We just use this one, positive 2, negative 7, negative 8, and plus 12. So there's no need for us to test this. Then after that, we will get the factors of 12 divided by the factors of 1 to get all the possible lists, and we will do trial and error until we get this, till we get this. So now look at this. Uh, I do hit here, I try negative 1, and it gives me 0. Then I use the remaining numbers and try another number again. And I try negative 2 and I get 0. After that, I use the remaining number and try another number again, 2, and I get 0. Then it give me x 1 and 3. So again, x raised to 0, x raised to 1. From right to left, 0 to 1 exponent. And if we simplify this, we have x. Simplify this, we have 3. So that is x plus 3. So if we do it and we find the value of x, we subtract 3 on both sides, we get the value of x is equal to 3. So now, we have this as our value of x. This will be our x-intercepts. See that this x is equal to 0, meaning any value of this x should be equal to 0, so that because if we divide it by negative 1, it will also give us x is equal to 0 pa rin. So this is x is equal to 0. So we have 5x intercept. Now, a while ago I taught you about how to do the y-intercept. All you need to do is to substitute 0 to x and compute for it, and you'll get the y-intercept. In this case, our y-intercept is 0 because as you can see, there is no constant term here. That's the case if there's no constant term. The y-intercept will be the origin. Now let's graph this. We have the list of our x-intercept, our y-intercept. The number of turning points is the degree, 5, minus 1 is equal to 4. That's why this is the maximum turning point. Now the end behavior is look at the leading coefficient. It is negative and it has odd exponents. That's why it has an end behavior of rises to the left and falls to the right. So there is no similar roots or similar factors. So that or there's no multiplicity to consider with. Meaning all of this, the graph will cross the x-axis at this value because there's no multiplicity. So now let's try to plug in all the points. Let's start with 0, 0. This is also our y-intercept. 1, 0. I will adjust the graph on two squares apart. This is 1, 0. This is negative 1, 0. Then 1, 2. This is 2, 0. 1, 2, 1, 2, 3. This is 3, negative 3, 0. Now our end behavior is like this. Okay. Now let's try to connect all the points. Again, remind you that all of this will cross the x-axis because there is no multiplicity. Okay, so this is the rough graph of this polynomial function. Now for number 3, same example. Let's do synthetic division to get the factor, the real zeros here. So if we test 1, we get 0. Again, the number that we're going to test are the factors of 12 divided by the factors of 1 because 1 is the leading coefficient. So if you try any factors of 12 that doesn't give you 0, then cross that out and try another one. Now if you get 0 on any numbers that you try, just use the remaining number and try another one again. In this case, I will try 2. I'll bring down 1. 2 times 1 is 2. 0, negative 2 plus 2, 0. 2 times 0 is 0. Negative 7, if we combine that, 2 times negative 7 is negative 14. 20 plus negative 14 is 6. 2 times 6 is 12. And that gives us 0. Now using the remaining number, you just need to do synthetic division again and do it and until you get 0. At this point, for the sake of the of discussion, I will try to find the x using by factoring this. Again, let's start with x raised to 0, x raised to 1, and x raised to 2. So if we factor this out, if we again x raised to 0, x raised to 1, x raised to 2. So this one is here, positive negative x, negative 3x, this is it, and 2, and that positive 2 equal to 0. Now we could factor this out, and the factor of this is this. And if we equate them to 0, we will get x is equal to 1 and x is equal to 2. So we have these 5 values of x that will make this polynomial function equal to 0. Now all you have to do is to add 0 on it and you get the x-intercepts. Now to get the y-intercepts, all you need to do is to substitute 0 to x, compute it, and you get this value. So now the value of y if x is 0 is 12, so therefore our y-intercept is 0, 12. Now to graph it, we have this is our x-intercept, our y-intercept. The number of turning points again, 5. The degree minus 1 is equal to 4. So that is our turning points. Our end behavior is by our leading coefficient. We have positive and we have an odd exponent. So that is falls to the right, falls to the left, and rise to the right. And there is no similar x-intercept. Oh no, we have one similar x-intercept, the 2. So 2, 0 are similar and 1, 0 are similar as well. So we have a multiplicity here. So we have multiplicity here, 1, multiplicity of 2. Now let's try to graph it. I will just plug in the points first. 1, 0, 1, 0, and 2, 0. Then we have negative 3, 0, 1, 2, 3. Now and 0, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's say that 12 is here. Now, the end behavior is like this. Okay. Now we have 4 turning points. Let's see. Now, remember that this is negative 3, 0. So meaning it only has one multiplicity. So the graph will cross it. It has nothing to do with that. And we will reach 12 until we get here. Then, now this one is 1, 0. If it is 1, 0, it has a multiplicity of 2. If it has a multiplicity of even number, this one will just touch the x-axis, the point, and will bounce back. It will not cross. Same as with 2, 0, it will not cross. And it will give us this graph. Again, because the multiplicity of this is 2, and 2 is even number, then it will just touch the graph. It will not cross the x-axis. It will touch the graph, bounce back, and decrease again, bounce back into 0 because 2, 0 has multiplicity of even number as well. So that's why it looks like this. So this is the rough graph of this polynomial function. Now let's try another example. So we'll need to graph this for polynomial function. As you can see, this polynomial function is already in factored form. So we don't need for us to bother factoring it. It will lessen our efforts in finding the x-intercepts. So let's try number 1. Now for number 1, let's solve for x-intercept. So all we need to do, if all of this, if we multiply them to each other, it will give them 0. Meaning, if this is 0, it doesn't matter what the value of this. Same goes with this, and same go with this, and same go with this. So all we need to do is to equate them all to 0. Then let's find the value of x using this. So the values of x are the following. So this one, the value of x is 1, 2, negative 4, and 3. So with that, we have this as our x-intercept. Now, using y-intercept, let's change, or let's substitute x to 0. So if we substitute 0 to x, I should say, so we will just do this. So 1, negative 2, 4, and 3. Then if we're going to multiply them all, we get negative 24. So this is our y-intercept. Now if we graph them, we will fill out all the what they call this, the given or the things that we need. Then after that, we'll graph them. So let me discuss you first why is it the maximum turning point is 3. Because as you can see, if you multiply x, 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 and x, you will get x raised to 4. Since this is x raised to 4, then the degree of this polynomial is 4. That is the degree. So 4 minus 1 is equal to 3. So this is the maximum turning point. Same as goes with this and behavior. All you need to do is to multiply the first term of the var of each factors. So x multiplied by x times x times x is x raised to 4. So this is positive and odd and even. So positive and even give us this end behavior. There is no multiplicity, so that's good to know. All of them will cross the x-axis at this value. So let's try to put it 1, 0, 2, 0, negative 4, 1, 2, 3, 4, negative 1, 2, 3, 4, negative 4, 0, and 3, 0. Then we have this and behavior. Now, the problem is y is 0, negative 24. Our graph will be lessened. So just imagine that negative 24 is below this. Or I just use this point as our negative 24. Again, this is not an approximate. This is 0, negative 24. The graph is not that accurate. Then all you have to do is to connect the dots. Okay. Your graph yan, should hit the point that you do. Mine is, I will write it again. I'm sorry. I'm bad at it. This is 0, negative 24. And behavior is this. So again, I'll do my best. Okay. Oh, sorry. Okay, so that's our graph. Sorry for my graph. It's just a rough graph. You could use Desmos, you could use GeoGebra to see if you have a at least close to the graph on that. Next, number 2. This is special because we have 2x as our value of x. So looking at this, it will give us a fraction that is negative 3 over 2x, 3 over 2. So this will be our x-intercept. For y-intercept, just change x to 0, multiply it, simplify it, and we will have 24 as our value of y if x is 0. Then we have 0, 24 as our y-intercept. So again, let's list all the things that we know. Y2, because 2x times x is 2x raised to 3. The leading coefficient, the degree is 3. So we have 3 minus 1 is equal to 2. So we have the maximum of 2 turning points. It doesn't necessarily 2, but it has a maximum number of 2 turning points. Now, add positive, where do we get this? We just multiply it again, the first the first term or the variable that the first term that or the x's of all the factors, and we get 2x raised to 3. And this is positive and this is odd. So that's why we have this end behavior. No multiplicity, no x-intercept occurs twice or more than one. So that this is good as it is. So all we need to do is to plot the point. First is negative 3 over 2. So negative 3 over 2, that is negative 1 and 1 half. So this is 1, this is 1 and 1 half. 2, 0, and 4, 0. Now, why this 0, 24? Our graph is not enough. If we take it one by one, I just assume that this is 0, 24, not in scale. Sorry for that. Our end behavior is this. Falls to the left and rise to the right, then we need to connect the point. All of this will pass through x-axis because all of this has appear only once or there's no multiplicity. And we have this as our rough graph or this example. Okay, I hope you learn or you pardon my graph. Let's go number 3. So let's equate them to 0. Now as you can see, this means x minus 3 times x minus 3 times x minus 3. So we have 3 sets of it. So it has a multiplicity of 3. And with this one, the value of x here is 1, negative 1, but we have a multiplicity of 2. Because this means x plus 1 multiplied by x plus 1. It will be hard for us if to get the value of x here is 3, the value of x here is 3, the value of x here is 3. That's why these zeros appear 3 times. That's why it has a multiplicity of 3. And this one is negative 1 and negative 1. These zeros appear twice, so that's why it has a multiplicity of 2. So the x-intercepts are the following. Now for y-intercepts, all we need to do is to set x to 0. Then negative 3 raised to 3 is negative 27. 1 raised to 2 is 1. And you get this as 27. Then our y-intercept is 0, 27. Okay, let's write what we know. Now again, how do we get the maximum number of turning points? All you have to do is to x raised to 3 is x cubed multiply by negative. Then this one is x raised to 2 is x squared. So we have negative x raised to 5. This is our leading coefficient. So 5 minus 1 is equal to 4. That's why this is the number of our turning points. Now this is negative and odd. That's why we have this as our end behavior. Again, we have this intercepts appears 3 times, so it has multiplicity of 3. And this appears twice, so that has a multiplicity of 2. Now let's graph it. Let's say that the 3, 0 muna. 3, 0, and negative 1, 0. Now, let's graph 0.27. It's in the upper part of the graph. So let's just assume that this point is 0.27. Just mark that as 0.27. Okay, our end behavior is like this and this. Okay, now let's pay attention to this one. This is 1, negative 1, 0. It has a multiplicity of 2. 2 is even. And if it is even number, it will just touches the x-axis. It will not cross the x-axis. So if we go there, we just cross the x-axis and go straight to our y. Then look at this. This is multiplicity of 3. This is odd. If that is odd number, it will cross the x-axis. But the thing is, 3 is greater than 1. So to make some distinction, we will just make it a flatten before we cross the x-axis. We will not just go straight to it like on the other one. If it is multiplicity of 1, then just like this. But in this case, we'll just flatten it first, flatten it a little, and cross it to x-axis. So that's the difference between that. The greater the odd multiplicity, the flatter it is. The greater the even multiplicity. So if we have this is our even number. If it is 4, it will be looking like this. Okay. If it is 2, it will look like this. Okay, so this is the rough graph of this polynomial function. Again, this 0.27 is not in this point. I'll just use this point for reference. You could just go upper until you get 0.27 point, and you need to touch that before you cross the y-axis. Okay, let's go for our last example. Okay, so the value of x here is 0, multiplicity of 2 because it's square, multiplicity of 2, positive 1, multiplicity of 3, and this is has multiplicity of 4. Okay, let's do it. It gives us 0, 0, 1, 0, and negative 2, 0. For y-intercept, it's easy because this one will create 0. So the value of this doesn't matter anymore. So y is equal to 0. So if we have our given, so let's check our leading coefficient, x squared times x raised to x squared multiplied by x raised to 3 multiplied by x raised to 4. So this is x raised to 9. So that's why the maximum turning point is 8. And this is positive odd. That's why we have this as our end behavior. Our multiplicity, to remind us, we have 2, 0, 2, 3, 1, and 4, negative 2. So let's put the point. 0, 0, this is our y-intercept as well. 1, 0, I will use twice the square. Negative 2, 0. 1, 2. So this is 1. Okay, and behavior is like this. Now let's be mindful. Negative 2, 0 has a multiplicity of 4. So we need to flatten this out, not just touching x-axis. We need to flatten it more, and it will not cross the x-axis. Now, if we go to 0, remember this, the 0 has multiplicity of 2. It should be narrower than the multiplicity of 4. That's why if we touch 0, we just turn it back again. We will not, we will not, we will not, they call this, we will not cross the x-axis. Now, 1 has multiplicity of 3. Multiplicity of 3, if we go that, we need to flatten and not a straight line. Okay. So as you can see, comparing multiplicity of 4 to multiplicity of 2, the 4 is wider and flattened to the x-axis compared to 2. So this is the rough graph of this polynomial function. So that's all for today. I hope you learned something today on how to do a rough draft. If you're having trouble on how to graph a polynomial function, you can use a supplemental material or support materials like Desmos and GeoGebra to answer it. So watch for out for my next videos and hope that you learned something today and hope you like and subscribe this video. So that's all. Thank you.